For as long as humans have gazed at the stars, the night sky has remained largely unchanged. Constellations have guided travelers, inspired myths, and connected civilizations across thousands of years. But soon, the calm familiarity of the night sky may be interrupted by a once-in-a-lifetime celestial event. A red supergiant star called Betelgeuse is nearing the end of its life. And when it finally explodes in a supernova, the night sky, as we know, it will never look the same again. Betelgeuse sits in the constellation Orion and is one of the brightest and most recognizable stars in the sky. It's the reddish point that marks the shoulder of Orion the Hunter, and it's been observed for centuries. At roughly 700 light-years away, Betelgeuse is relatively close in astronomical terms. That proximity is what makes it so intriguing and so important. This isn't just about a star dying. It's about witnessing an event so rare and powerful that it could rival the brightness of the full moon, be visible during the day for weeks, and outshine every other star in the sky for months. For astronomers, it's a cosmic spectacle. For humanity, it could become the most visually stunning astronomical event of modern times. To understand why Betelgeuse is so significant, we need to take a closer look at what kind of star it is. Betelgeuse is a red supergiant, a massive star in the late stages of its life. Stars like our Sun burn hydrogen for billions of years, fusing it into helium and releasing energy. But Betelgeuse is many times more massive than the Sun. It burns through its fuel at a furious rate. Over its short life, just a few million years, it has gone through hydrogen, helium, and now heavier elements like carbon, neon, and oxygen. The heavier the element, the faster it burns. Eventually, iron will begin to accumulate in the core. Iron is a problem. It doesn't produce energy when fused. It consumes it. As iron builds up, the star can no longer support its own immense weight. Gravity wins. The core collapses in a fraction of a second. And what follows is one of the most powerful explosions in the universe. A core collapse supernova. When Betelgeuse goes supernova, the collapse will create a shock wave that tears the star apart. Enormous amounts of energy and stellar material will be blasted into space, lighting up the cosmos. From Earth, it will be impossible to miss. Depending on how the explosion unfolds and how much dust and gas are in the way, Betelgeuse could become brighter than any star we've ever seen with the naked eye. It might appear as a blazing point of light in Orion, completely outshining its familiar neighbors. For weeks, maybe months, it could be visible during the day. At night, it would cast shadows. It would dominate the sky like a second sun. Imagine stepping outside at midnight and seeing a brilliant light where darkness once reigned. For ancient civilizations, this would have been seen as a divine omen. For us, it's a rare chance to witness the death of a giant star in real time. But don't worry, this explosion poses no danger to Earth. Despite how dramatic it will appear, Betelgeuse is far enough away that the radiation and material from the supernova won't reach us in any harmful way. It's the perfect distance. Close enough to observe in stunning detail, but far enough to be completely safe. In fact, this could be one of the best-studied supernovae in history, thanks to our modern instruments and technology. What's even more fascinating is that this event might already have happened. Light takes time to travel. If Betelgeuse is 700 light-years away, then any changes we see now actually occurred 700 years ago. It's possible that Betelgeuse has already exploded and the light just hasn't reached us yet. Every night we look up, we're looking into the past, watching a version of Betelgeuse that no longer exists. When the light from the explosion finally arrives, it will be like opening a time capsule from the Middle Ages. Astronomers have been watching Betelgeuse closely for signs that the end is near. In late 2019 and early 2020, something strange happened. Betelgeuse dimmed dramatically, much more than usual. It lost more than half its brightness, and people began to speculate. Was this the beginning of the end? Could we be witnessing the final days of Betelgeuse? As it turned out, the dimming was caused by a massive ejection of material that temporarily obscured the star. It wasn't the supernova event, but it was a reminder that Betelgeuse is unstable and its end could come at any time in 1,000 years, 100, or even tomorrow. We simply don't know. What we do know is that it's coming. Astronomers use a variety of tools to keep tabs on Betelgeuse: optical telescopes, infrared sensors, radio observatories, and space-based instruments like the Hubble Space Telescope and James Webb. These tools help them monitor the star's temperature, brightness, and spectral lines. Every wobble, pulse, or dimming event is scrutinized for clues. The hope is that when the moment finally arrives, we'll be ready to catch it from the very first second. One of the things scientists are especially interested in is the neutrino burst that will come from the supernova. Neutrinos are nearly massless particles that pass through almost everything. During a core collapse, an enormous flood of neutrinos escapes the star's core. These particles travel faster than light does through the outer layers of the star. So, neutrino detectors on Earth will be the first to know when Betelgeuse explodes. We could get a few hours warning before the visible light hits, giving telescopes a head start. Even after the light show fades, the remnants of Betelgeuse explosion will linger for centuries. A supernova remnant, a cloud of glowing gas and dust, will expand into space, enriching the cosmos with heavy elements. This material will eventually become part of new stars, planets, and maybe even life. Every atom of gold, silver, and uranium on Earth came from supernovae like this one. Betelgeuse death will contribute to the ongoing cycle of cosmic creation. And then there's the night sky itself. Once the explosion dims and the dust settles, Betelgeuse will be gone. Orion's shoulder will be missing a star. A piece of our cultural and astronomical history will vanish, replaced by a lingering nebula where a giant once stood. Future generations will look up and see a different Orion, missing one of its most iconic features. Star charts will be updated. The stories we tell will change. And all of us alive today might be among the only humans ever to remember what Orion looked like before the supernova. This isn't just about one star dying. It's about a transformation that spans science, history, and human experience. The last time a nearby supernova was visible to the naked eye was in 1604, long before the telescope was even invented. That event, known as Kepler's supernova, was recorded by astronomers across Europe and Asia. But its light faded long ago. Betelgeuse promises something even more spectacular. And we now have the tools to capture it in exquisite detail. Modern observatories will monitor the explosion across the entire electromagnetic spectrum from gamma rays to radio waves. Satellites will track high